Hello, my name is Chris O'Connor. I'm a senior at the University of Connecticut School of Engineering. My advisor for this project is Professor Ugur Pasaogullari. This is an introduction to renewable electrochemical energy systems. Electrochemical energy is the process of converting chemical energy to electricity and vice versa. Energy conversion occurs through reduction-oxidation reactions where an atom is oxidized with the loss of an electron and another atom is reduced with the gaining of the electron. There are two types of electrochemical conversion cells, galvanic and electrolytic. Galvanic or voltaic cells convert chemical energy into electrical energy via spontaneous reactions. A simple example would be your everyday household battery. Electrolytic cells work by converting electrical energy into chemical energy via non-spontaneous redox reactions. An example of this would be an electrolyzer, a device used to split water into its constituent molecules of hydrogen and oxygen. Electrochemical energy offers a solution to one of the most pressing needs our world currently faces, clean energy. The urgency for clean energy can be illustrated by rising temperatures around the world. Since the 19th century, the surface of the Earth has warmed 2 degrees Fahrenheit. 16 of the last 17 years were the hottest years in recorded history, with most warming occurring during the last 35 years. It is undeniable. The Earth is warming at an unprecedented rate. What is causing this problem? The greenhouse effect is a natural process where solar radiation is absorbed by the Earth and reflected into the atmosphere. Greenhouse gases like carbon dioxide can absorb solar radiation and re-emit it in all directions. As greenhouse gases continue to fill our atmosphere, solar radiation accumulates, increasing the temperature of the planet and atmosphere. Pictured left is the annual CO2 emissions produced from the burning of fossil fuels and cement production. While the United States has been relatively stagnant with emission levels, global emissions continue to rise at an alarming rate. Looking at the historical trends of CO2 emissions gathered with data collected from ice caps, current levels of CO2 are unprecedented by hundreds of parts per million. In the U.S., the majority of these CO2 emissions come from the production of electricity as well as the transportation and industrial sectors. The rise in global temperatures can be measured and is directly attributed to our CO2 emissions. It will take worldwide collaboration of all peoples and industries to eliminate our reliance on fossil fuels, but it is especially up to the energy sector to solve this problem. The time for clean energy was decades ago. Hydrogen fuel cells are an underutilized technology that offer promising opportunities to produce clean energy with no CO2 emissions. The only byproducts fuel cells create are electricity, heat, and water. In 2006, Yukon partnered with UTC Power to build a 400 kilowatt fuel cell system to provide clean energy to parts of the store's campus. Yukon's fuel cell reduces carbon emissions by approximately 600,000 pounds of CO2 per year. Fuel cells like Yukon's provide great opportunity for clean energy solutions. Fuel cells consist of 2 electrodes, an anode and a cathode, separated by an electrolyte. A fuel, typically hydrogen, is continuously fed to the anode while an oxidant is applied to the cathode. As hydrogen enters the anode, a catalyst separates the protons and electrons, which take different paths to the cathode. As electrons exit an external circuit, the flow creates electricity. Protons move through the electrolyte to the cathode, bonding with electrons and oxygen, producing water and excess heat in the process. Approximately 96% of all hydrogen is produced using fossil fuels, 48% with natural gas, 30% with oil, and 18% through coal gasification. Only 4% of hydrogen is produced using renewable energy. Although the hydrogen produced provides clean energy, the production process relies on fossil fuels, contributing to the production of greenhouse gases. This is considered a bridge technology, and if we want to eliminate our reliance on fossil fuels, we must utilize renewable technologies for hydrogen production. Hydrogen produced by renewables like solar and wind can eliminate the current reliance on fossil fuels. Electrolysis is the process of using electricity to split water into hydrogen and oxygen gases using a relatively simple device called an electrolyzer. At the anode, water reacts to form oxygen gas and hydrogen protons. At the cathode, hydrogen ions combine with electrons to produce hydrogen gas. Although the electricity produced that's stored with hydrogen gas would be better stored as electricity, hydrogen is an established source of energy industries have incorporated into their energy profiles. Renewable electrolysis offers a carbon-free approach to hydrogen production. To demonstrate a simple approach to renewable hydrogen production, I built a simple electrolyzer that uses solar panels to produce carbon-free hydrogen. This can be built with the following parts: an ordinary airtight container, potassium hydroxide for an electrolyte, some water-resistant glue, recycled bottle tops, solid 14-gauge wire. I chose solid wire because it could be molded into shape, so we wouldn't have to use parts to hold it in place. A platinized electrode. This ended up being too big and ultimately wasn't used. Instead, I used two 6-inch 30-gauge platinum wires, two 3-volt solar panels, some alligator clips, plastic tubing with tube splicers and clamps, and diffused water, and a birthday balloon for gas collection. For tools, I just use a hand drill, soldering iron, and a hot glue gun. Begin by drilling holes into the lid using a bit equal to your tube diameter. Reaction cells can be made by cutting 2 bottles and gluing them to the lid, holes centered. Connect the tube to the splicers, use the clamps if needed, and insert them through the lid holes. Seal with glue, repeating this process 2 or 3 times. Then, measure the lengths needed to center your electrodes in the reaction cells and shape your wire accordingly. To make the electrodes, roll the platinum wire around a pen to create coils. Solder platinum onto the wire and seal with glue. Next, drill holes into the sides of the container and feed the wire through, centering the platinum electrodes. Seal the holes with glue and fill the container with water to test all the seals. Wearing gloves and safety goggles in a well-ventilated area, mix a 30% potassium hydroxide solution. Once fully dissolved, assemble the container for testing. Test your solar panels individually and in series to check wiring and voltage. Connect to the terminals to begin testing and clean hydrogen production. Alkaline electrolysis has been used for decades in the chemical industry as well as the military to produce hydrogen and its isotopes. The potassium hydroxide used creates an alkaline electrolyte solution, allowing ions to conduct electricity. When a current is applied to the solution, water molecules break down, forming hydrogen at the cathode and oxygen at the anode. This was a simple demonstration how renewable technologies can be used to create clean hydrogen production. Is this the answer to our clean energy needs? Definitely not, but it is one of them. There are still many hurdles hydrogen must overcome before it's a competitive energy. Cost of production remains high, and compression and storage of hydrogen still has some technological barriers. If we continue to invest in these technologies to overcome these setbacks, renewable hydrogen production can offer carbon-free energy while providing economic growth. The United States has set a goal to reach 100% carbon-free electricity by 2035. If we are to meet this goal, electrochemical energy systems like fuel cells that utilize clean hydrogen will be an essential part of the solution. Thanks for watching.